Recording. Okay, we're recording.
Hello, good morning, everyone. Thank you for taking the time out of your day to attend our flexible modeling webinar here using Creo Parametric 2.0. My name is Julian Wagner. I am a Northern California account executive here at NXREV. And I'm joined today by Alberto Mazzaroto, who is one of our lead applications engineers. So, first thing we're going to do today is just have a quick little agenda here. I want to talk to you guys a little bit first about NXREV and some of the added value that we provide here in the United States. Then from there, we're just going to jump straight into the demo. We do encourage that you ask that you ask questions throughout the demo. We'll do our very best to answer them as we go along. If we do not happen to get to your question during the demo, we will go ahead and have a Q&A session towards the end. So we will get to your question. So to start, a little bit about NXREV. We are PTC's largest partner on the West Coast. We have been partnered with PTC for over 10 years now. So when it comes to experience, we're definitely not lacking as it relates to product development at large. We are based here in Santa Clara, California. We also have offices up in the Pacific Northwest, as well as down in Southern California. I think one thing we all really like about NXREV is the fact that we get to work with some of the coolest customers, or I should say companies that develop products in the world. And one of the things we pride ourselves on is our ability to provide great local support for them, regardless of where they are. And then, I kind of want to go over some of the different resources that we provide here at NXREV. First of which are our Power Hours. Power Hours are free training sessions that happen every Friday during the lunch hour, so from noon to 1. Essentially, these are 1-hour tips and tricks sessions that are done with our application engineers that cover a whole span of topics all related to CAD and product development lifecycle, or data lifecycle management, if you will. So you could have a day where it's all CAD-centric, or another day that's specifically focusing on surfacing, and another day on the best practices of data management. So our customer base really does enjoy these Power Hours. Again, if you need to find them, they are on the NXREV.com website under training and Power Hours. You can also register for them there. There's an archive of older Power Hours, and subsequently we do record them so that you can maybe get a hold of one that you perhaps missed and really wanted to see. Along with Power Hours, we also hold instructor-led courses. We are a PTC certified training partner here on the West Coast, and we do have training facilities not only here in Santa Clara, but again also up in the Northwest as well as down in Southern California. The great thing about our training is that we can do the PTC classes, but we can also do custom classes for your company. Not only can we do them here at NXREV at our various facilities, but we can also come on site to you at your company and do training there. And again, when it comes to experience, we have application engineers that have been training one for PTC and then for NXREV for many years, so there's definitely no shortage of capabilities and all of that. So with that, I'm going to pass it out to Alberto, who's going to start going into the flexible model. And again, I just want to thank all of you for attending today. I really hope that you're getting a lot out of this new solution that not only we are excited about, but that is gaining a lot of great notoriety within the CAD section, or the CAD industry, if you will. So without further ado, Alberto, take it away.
Julian, thank you for that introduction. Again, my name is Alberto Mazzaroto, and I'm one of the many application engineers here at NXREV. Just before we start the demonstration, I just want to talk a little bit about some of the pains that we'd have working with not only our regular models, but those much disliked STEP and IGES files. So, I mean, why are we given STEP and IGES files? In some cases, it has to do with intellectual property. Customers don't want everybody to see how the part was actually created, simply to protect themselves. In other cases, it's a lot less important in that we just don't all have the same CAD tool. So a lot of times we're simply having to convert the STEP and IGES just to work with other people. That brings us to rework. So if we are starting to work with step or IGES files, many times our engineers are being forced to redesign, reinvent the wheel, as it were, on these parts that have already been created. That's not a good use of an engineer's time. This rework and redesign is very costly in terms of time and thusly money. In terms of creating changes, and I'm talking about changes in your own parametric, fully defined models, last-minute changes can be difficult because in some cases we do have very rigidly defined parts. These well-designed parts with a lot of design intent are not going to allow you to repurpose them to create something new. You're going to have to change this intent, which in some cases can be very, very difficult and time-consuming. That said, the opposite is true as well. When working with poorly defined parts that someone with maybe very little CAD experience designed, it's going to be difficult to make changes simply because of the maybe incorrect way a part was designed from the start. So flexible modeling, how on earth is that going to help with some of these imported data? Let's start with the STEP and IGES files. Well, number one, you're going to bring in this STEP file or this IGES file, and we're actually going to start the demonstration in by bringing a native SolidWorks file, an SLD PRT, into Creo Parametric. And now when these files come in, we are simply going to have one block. That's it. We're not going to have a model tree. We're not going to have much to work with, and that has always been a headache. But the beauty of flexible modeling is we are no longer in need to actually redesign these parts. We're able to use direct modeling technology, which was pioneered in the early 80s by Hewlett-Packard and their Co-Create tool, to actually take surfaces, curves, features, and edit them directly. We're able to change the design intent of these fully defined, rigidly bound parametric models very easily as well, simply because we're not in much need of the parametrics that were previously applied to the model. We're simply going to take these features and make direct edits to them. And again, the same is going to be true with these poorly defined models. No longer are we going to have to deal with the poor design practices of somebody else. We can simply take the part and make these late-stage design changes rapidly. Now, what on earth does this all mean to us? Well, the engineers are going to be able to make these changes a heck of a lot faster and complete their projects sooner. This is going to increase productivity, and therefore your time to market is going to be significantly less. And of course, what is this going to bring to the company? What we all want, increased revenue. Now, I think we'll go ahead and get started with the presentation, or I'm sorry, the demonstration. So I think what we're going to start with here is working with a SolidWorks part. And if you can, I'm just going to hover over this right here, you can see that we have an SLD PRT SolidWorks part. I'm going to double click on it, and we're going to be prompted with this screen here, which is going to ask us if you want to enable ATB. Now that stands for Advanced Topology Bus. Now what that's going to do, I'm going to go ahead and enable that. What that's going to do is actually allow us to work with another SolidWorks user, basically coexist with the SolidWorks user, bring in the part, and when that SolidWorks part is changed, it is going to be reflected in the assembly that we're using it in. We will be notified of it, but it's going to allow us to work in unison with another engineer using a different CAD tool altogether. So here's our part, and as we can see here in the model, we've really got nothing to work with. So let's just kind of hover over this, and what I think I want to do, and this is going to be the same for any type of parametric tool. I want to get rid of this hole right here. So how would we normally do that? Now, just for the sake of this demonstration, let's just keep an eye on the time. If I have to get rid of this hole, how long is that going to take? Well, you know, it's a pretty simple thing, so let's get started. We'll want to create an extrusion on this surface right here, and we'll just basically sketch a circle about this center point, make it a little bit larger, complete that, hit OK, and now the extrusion, well, you know, we'll even give this a little bit of intelligence. We'll flip the extrusion around, and we'll make it extrude about a face, and we'll select this face right here. Okay, and complete. You know, not tough. This took us 15 seconds, I think. Pretty simple to do. I think any CAD tool will be able to make that change very easily. The problem is, you know, I think I can make this change faster. So what I'm going to do is actually undo that change, and I'm going to work in flexible modeling. Before I go there, I do want to pause for a moment. Many of you maybe haven't seen Creo parametric before, so I will take a moment to kind of just show you some of the of how it actually works. The first thing you're going to notice is this user interface. Very similar to what you'd see in the Microsoft line of products, Office, for example. This is more than just a passing similarity. PTC actually licensed this whole look and feel from Microsoft. So we are going to limit the amount of menus that we're going to basically lose tools in. We are going to have little drop downs, as you can see down here. And these can be fully customized. So if there's something that you don't do very often, maybe you rarely do any type of ribs or trajectory ribs, we can always remove that and replace it with something else here that is more important to you. Now, if you are new to Creo Parametric, we do have a tool here called the command search. So if you do want to create an extrude and you don't know where it is, well, we can type it in here. Or maybe you want to add a parameter to your model. Simply by typing in the beginning part of parameter, we are going to find that it's going to filter anything that has PARA in it. For example, about Creo Parametric help, some other parameters here, but what we really want is parameters for model intent. Simply by hovering over parameters, we are going to see that it's going to highlight where parameters is here in the ribbon. So we can click on it here, or we can click on parameters here. And simple as that, we can basically gather parameters about what we're working with. Okay. So I think I'll stop on that. I know we are going to use a filter down here in a moment, but I'll cover that when we get there. So I want to go into flexible modeling. We're going to find the flexible modeling tab right here. And now what I want to do is come down over here again, and I want to get rid of this 4 and see how fast I can do that. Now before that, you can see that as I hover over everything, it is automatically selecting geometry. I would actually like it to select simply surface regions. And this is basically the filter right here. So it'll allow us to more easily filter what we're actually going to hover over so that we can select something that's more important to us. So in this case, I'm going to select the circle, and I'm going to remove it. Pardon me. And that's it. Now, I may have done that kind of quick, so I'm going to undo that and do it again. I simply selected the inside of the cylinder, I hit remove, and that was it. Now, it's an easy enough task in a parametric tool, but in Creo Parametric using flexible modeling, it took me a split second. In fact, it was so quick that I did it again. But not only can I remove these features quickly, but I can edit them quickly as well. So I'm going to select the feature again, and I'm actually going to come up here to modify analytic. What this is going to do is give me an existing radius in this case, and the ability to change it, just like a parametric tool. Now what we're seeing here is that this radius is 15.5 millimeters. I can change the units. It appears that it's in MKS, and I can easily change it to MMKS. But I think we're just working it right now in MKS. So basically up here, I can change the radius here, I can change the radius down here. Let's make the radius larger. Let's make it 17 units or millimeters. So enter. And that's it. You see it's changed dynamically from the original size to the larger size. But if I want to make it smaller, let's go ahead. In this case, we're just going to select this little white box and just drag it smaller. Okay? And that's really all there is to it. I can drag things dynamically, or I can make them, I can change them numerically.
If I may interject,
of course.
There's a quick question. Could you talk a little bit about exactly what goes on in the history tree as you're making these changes to the part?
Yes. I'm glad you brought that up. So, when I opened this part up, I had simply a block. As I make changes to this part, the changes that I make will go into the model tree. Same thing happens in a parametric modeler. But I know in this particular case we are using direct modeling, which historically does not have a model tree. Nevertheless, all the changes that we make here are going to be listed in the model tree. We can simply right-click and edit the definition of these changes and actually go back in and edit them just like you would with any other parametric change. Okay, does that answer your question? Okay, very good. All right, so from here, let's go ahead and make another change. So the one we just did a moment ago was pretty easy to deal with. What I want to focus on now is making a change to a round. So what I want to do is actually select the entire round here, and I want to get rid of it. So that's it. I'm just hit remove, hit OK, and the round is gone. I mean, again, that took a split second. And due to these contours here, this is not an easy task to do. So since we're dealing with rounds, let's go ahead and go back to this round over here. Now let's edit this one. So I'm going to select that, and now I'm going to go to Edit Round. Okay, pretty straightforward. Once I select a portion of the round, I select the entire round, and I go to Edit it. Now that I'm in here, we can see that this round is 1 millimeter. I'm going to change it, however, to 1/4 millimeter. Right? And we're going to get the a dynamic update here, so we can see how small it is in 1/4 millimeter. We're going to accept that change, and we're all set. Okay, so I was able to make a change to a round, kind of a strange little round here, in a split second. Since we are working in this area, let's note this little gap here. Okay, I'll kind of zoom out and give you a better idea of what this gap is. So what's going to happen is you can put 2 screws in here, and it's going to provide a compression fit around a shaft that goes through this. So what I need to do is actually design requirement is change, and I need to make this gap larger. You know, again, not a very difficult thing to do in parametrics. We would have to simply create a plane on this face and do an extrude cut. Not really too difficult. Well, let's see if we can make this a little bit easier. I'm going to select the surface, and I'm going to go to Move. And now we've been given 3 axes in which to move. The problem is, really, none of these axes are in line with the direction that I'd like to go. So I'm going to select an edge that is the direction that I'd like to move. So simply by clicking on an edge, we're going to see that the dragger has changed to a single direction. So I'm going to drag it, and we're going to see that it's going to give us some numeric value here that we can apply. We can either drag it dynamically, or in this case, actually, we just want to move it for, I want to move it 2 millimeters. So let's go ahead and give it a value of 2 millimeters, and that's it. Okay, I gave it the value. It's going to show us dynamically what the actual difference is going to be, and I'm going to accept that change. And we've completed that move in a few seconds. In fact, since we're going to do a little bit more work on this area, I want to get rid of this chamfer. Okay, it's kind of small. You can see it there. I want to get rid of this chamfer, so I'm going to select that. And I know there's a little piece right here, so I'm going to select this chamfer also. And again, go to Remove. Okay, it's removed the chamfer. And we're all set. So zoom in, you see no more chamfer. Since we have been able to do that, what I'm going to do is change the overall radius of this bore. So I'm going to select the bore, and I'm going to go once again to Modify Analytic. And we'll just make it we'll make it smaller. Okay. Now we can tell that as I make this smaller, we are developing a bit of a problem. Note this round that has appeared. I guess the original one had a bit of a round. I didn't notice. So we're going to have to go ahead and make some changes here. Now, I could delete this step, delete the round, and come back and redo it. But, you know, I think I can make this a little bit simpler. I'm going to click on this and simply suppress this particular feature and come in here, select the round, remove it, and come back to the feature that we suppressed and just resume it. Okay, and there we have it. So again, just another way to save another step. You're not having to go back or reorder the model tree. You can just suppress it for a moment, get rid of it, and then resume it. You know, I'd like to actually go over something now that is kind of easy to do in parametrics. Now what I'd like to look at is, let's say a requirement has changed. We changed manufacturers, and the shaft that bolts here is a different, has this different flange height. So I'm going to select this surface, and I'm going to pull it down. So I'm going to move it. Actually, in this case, I think we'll offset it. So we can offset it downwards. Okay, pretty simply, we can pull it down 10 millimeters. Maybe we only want it to be 5 millimeters. And there we go. Even in parametrics, you'd simply select that surface that you want to create a plane on or extrude on, create a circle, and extrude cut. Not a big deal. What might be a little bit tougher to work with is this particular surface here, okay? We do have some interesting rounds over here that the sketch may have created. And in order to recreate that, it might be a little time consuming. So again, let's select the surface here. And I'm just going to go ahead and move it. So we're going to pull it down a bit. And again, I can go to move. I can go to offset, and we'll talk about the differences between those two in a moment. But just note that I was able to select the surface and move it in one click. I'm going to accept that change, and I'm all set. Okay. Again, sorry, go ahead.
I'm sorry, Alberto, we do have a quick question, and this is in relation to something that you spoke to us about a little bit earlier. Is it difficult to change your units in Creo?
Say you wanted to change the inches.
Oh, I'm glad you brought that up. You know, it isn't. Let's go ahead and do that right now. We go to File, and basically under Prepare, we go to Model Properties. And this is where we're going to have everything pertaining to a specific model, such as your mass property, your accuracy, type of material. In this case, we are going to see units, and we're in MKS. So if we go to Change right here, we can simply change it to MMKS. And this is a metric part, and I think using MMKS would be a little easier. I can go ahead and set it to that. Just a side note. In some cases, we do make the mistake of creating something in the inch system that we accidentally wanted in metrics. So we can convert, for example, 1 inch to 25.4 millimeters. Of course, that's the correct version. However, should we make that mistake, we can always interpret the dimensions. So 1 inch would become 1 millimeter, and vice versa. 1 millimeter would become 1 inch. So in some cases, that'll be very useful. And in this case, I think we just want to go ahead and convert from MKS to MMKS. So we'll hit OK, and it's simple as that. I mean, now we just basically have to get everything back in here. And there we go. Okay, no, not a problem. So what I want to go ahead and do is make some changes now on this on these two ramps. Now, before I do that, what I'd actually like to do is work a little bit with these ramps up here. So what I want to do is zoom in here and just note that these two guys are symmetric. I mean, it looks like they're symmetric about this particular about this center point here. So let's give these guys some intelligence. I'm going to select this surface here and this surface here, and I'm going to apply symmetry recognition. Okay, and that's it. So now what we've told Creo Parametric is that these two surfaces are going to be symmetric. From here, what I want to do is select this surface, and I'm going to go ahead and go to Boss with Secondary. Now, I've been going to Boss with Secondary kind of often. We just note that we can simply select the main unit, the unit with another feature, and in fact, we also have the ability to set the cut or cut with an additional feature. And here is our round and our round with secondary. So if the round goes around an edge, we can use that as well. So again, let's just select the surface, and we'll select this particular boss. And now we're going to go to move. Okay. So what we'll go ahead and do here is we'll just go ahead and move it to the right. By right, of course, I mean left. And simple enough. Now, under attachment, we will also have the ability to move this either with the round, which it was sitting on, or we can move it without the round geometry. Now, obviously, we have the ability to select the round geometry earlier and remove it. But in this case, let's go ahead and remove it in one step. So I remove the round geometry, and let's go ahead and spin it around this plane here, about the vertical axis. But why stop there? Let's spin it about this particular plane here also. And again, we've gotten this far, so we might as well do a little bit more and spin it about this plane here. Okay. Now earlier we did mention that we had some symmetry here. So let's go ahead and apply that symmetry. So under options, we are going to have a symmetry option here. So I'm just going to select the symmetry recognition that we did earlier and just watch what's going to happen to the other ramp. It will automatically get all of the symmetry applied to it. In fact, this might look a little neater if I turn the rounds back on. So the rounds are going to be turned back on. They are going to update dynamically. And now, when we've completed this, we've got some fairly neat looking rounds here. So just note that we were able to turn this, this particular ramp in 3 different planes. Now, even with a native part that is fully defined, you are not going to be able to do this very easily at all. At this point here, I think I'd like to actually get out of this particular model. And what I want to do is focus on a step file. I think we've talked a little bit about opening up a native SolidWorks part. In this case here, what we're going to do is open up this particular step model, step file right there. And the reason we're going to do this is simply to point out that we are going to give you the ability to do the same type of changes on a variety of models. So this is our part here. Again, look at the model tree. We've got absolutely nothing in there. So once again, we're kind of stuck with nothing. The first thing I like to focus on is, number one, we are working with kind of an in-depth manifold here. A lot of these cylinders, and even a simple change such as just moving this particular cylinder is not going to be an easy one. So here's what we're going to do. We're going to go into our flexible modeling, and I'm going to want to select this surface, and I'm going to select emboss with secondary. And we'll go ahead and go to move. And the reason I like using move is because it is going to give us these 3 different axes of rotation. So I'm going to pull it this way. Now just note that the round is coming with it automatically, and you have the ability to get rid of the round as well. But just note what happens as I drag it over the edge here. Okay, so the round is changing dynamically, and as I go past until the cylinder actually comes off, it is going to update automatically. So note that the cylinder did drag off the surface, and it went ahead and completed what the shape was going to be. So again, I don't want to just stop there. Let's add an angle, and we'll do that once again. Okay. Now let's just think about this for a moment. Even in a parametric modeling tool, any parametric modeling tool, this is not an easy task to complete. With Creo Parametrics flexible modeling, simply because it's working with a direct modeling paradigm, these are very simple modifications to complete. So speaking of parametric modeling tools, there's a lot of similarities between working with a parametric tool such as Creo Parametric as well as SolidWorks in terms of how to mirror something. So let's say we want to actually mirror this boss right here. Okay, how are we going to do that? Well, we're going to have to select a mirror plane. But as we brought this part in here as a step file, we are not going to have any planes visible even if I turn the plane display on, because they just don't exist yet. So simple enough. We'll go to model, and we are going to go ahead and create a plane. I'm going to use my surface filter here just to make things a little bit easier, and we'll do a plane through that axis, normal to that plane, and we're all set. So back to flexible modeling. We will select this surface here, do boss with secondary, and go to mirror. Simple as selecting a mirror plane. Okay, anybody who's done a mirror in parametric modeling, not a problem. You'll be able to do a mirror in flexible modeling. Now just note before I accept this, I'm going to spin this around a little bit, maybe zoom in. Just note that it brought along the round, and it conformed to this surface automatically. So I'll complete, oh, I'm sorry.
Yeah, so Alberto, there's actually a question about that. Someone would like to know if you're still able to mirror the feature if the surface the feature is sitting on is actually different.
Ah, I see. Yes, yes, you are able to do that. I know that these look similar. If I give you a better view here, you'll note that these manifolds are in different locations. In fact, on this example here, it did have two manifolds that actually went underneath this particular feature. So yes, it does not matter what the surface mirrored is going to be mirrored onto, as long as it is mirroring about a plane. So great question, and yes, you can mirror it onto absolutely any surface you need. So speaking of surfaces, what we're going to do now is actually substitute a surface. We can see this feature right here is kind of a triangular flange. What I'm going to do is substitute this triangular surface for this rounded surface. So again, I'm just going to select this surface right here. Zoom in for that surface, and we're going to get this back one also. Okay. Once we've done that, we're simply going to go and substitute right here in the flexible modeling menu. And simple enough, it's asking me what to substitute. So I'm going to open up the references just to show you what it's asking. We have the substituted areas. Now it's asking what we want to use to actually substitute. So we're going to select this surface here. We are going to get a dynamic preview, but just note that in this case, the substitution is going to add material. We also have the ability, simply by clicking on this little arrow here, to remove material in a specific shape. What you'll note is it is only going to remove material up until an edge. So obviously the extrusion ended at this hole, and it ended at this edge here. In this case, we do want to add material, so let me just flip that arrow around again, complete that, and that's it. So we've changed the entire shape of that part from a triangle to a circle. And again, this could be one of those design intent things where you're trying to reference something that is going to be very difficult to do in a rigidly defined model. I'd like to next move on to a different part. In this case, we're going to use a native ProEngineer file, okay? And that is going to be this particular breakdance. So the first thing I want to do is, obviously this thing is completely comprised of patterns. The problem is, as you look in the model tree, someone once again stripped out all the information because they wanted to protect their intellectual property. So what I'm going to do now is go to flexible modeling, and I actually want to go to pattern recognition up here. Oh, there you go. And I'm just going to select this face. What's going to happen now is it's going to notice all of the bores in the face and note that there is a pattern to them. So if I do go back to the pattern here and edit the definition, you'll note that I've got all these little black dots in the center of these holes. And what that means is if I select these black dots, they will turn white, and this means that that instance will be omitted. So I'm going to try and create a little pattern here, complete this feature, and note that when I've finished it, those inside bores are gone. I did not have to select specific surfaces, do an extrusion, or use a feature recognition tool that might not actually catch that there's a pattern here. Flexible modeling is going to allow you to find the pattern and use it instantly. But again, I simply use the pattern recognition tool for something very basic like a hole. Okay, let's use it for something a little more complicated like an entire feature. So let's zoom into this guy, and I'm going to select this and do boss as secondary. Just note that it is not automatically selecting these rounds, so we are going to want to include those also since they are going to be part of the feature. So once I've done that, by simply selecting pattern recognition once again, it is automatically going to note that we have a pattern of these 5 tabs. If I go under options and allow myself to edit these instances, I can go from 5 to 6 instances, and we'll do 6 instances every 60 degrees. I'm going to complete that, and there we have it. Okay, so we changed from 5 to 6. Why would we do this? Well, maybe the manufacturer that we're getting the hubs from had to be replaced, and the new one has 6 lug brake disc holes instead of 5. This type of change is going to be very, very quick and very, very easy because of flexible modeling. And again, because we did pattern recognition, we can come back to it, once again, edit the definition, And maybe we want to get rid of a couple of these instances. So I'm going to complete that. And just note that we're going to go from the 6 tabs to the 4 tabs. Okay. That pretty much completes our demonstration on flexible modeling. Before I wrap up, however, I would like to go ahead and go over a bit of what we talked about earlier. So just a bit of a recap. The shape-based selection, we did talk a little bit about selecting a boss with secondary, even a cut or cut with secondary. But one of my favorite bits was definitely the ability to select rounds. In terms of move, we were able to select a face and move it about a certain axis or about a certain plane. Offset is going to give us the ability to move about only a certain axis or a certain radius. And typically we are going to use a numerical value to start the offset. We don't have to. We can drag it dynamically, but in most of the examples I did, we did move it about a certain value. Substitution is going to, again, allow us to substitute an existing surface for a new surface. We did the example with the little triangle tab and the rounded, converting it to that rounded surface. Probably one of my favorite features has to be Edit Round. Again, we simply selected a round, either deleted it or changed the value. Now, in many cases, maybe this isn't going to be useful to you, but I know of one specific example that is going to be critical. If any part that you're working on has to go to a computational fluid, through a computational fluid dynamics process, we can't have rounds. Simply by selecting the rounds and hitting delete is going to allow the tool to go through a CFD tool without any problems. This will take a matter of minutes versus very likely having to rebuild the entire part. We focused a little bit on the mirror tool, and again, mirroring very similar to the way you would mirror in a parametric modeler. However, remember, we are working with a part that has absolutely no intelligence, and therefore, we have the ability to mirror any feature that we select about a plane. Just note that if you are working in a parametric modeler, such as Creo Parametric, and have a fully defined model tree, you will still be able to mirror in flexible modeling to get around any of those rigid design intents that you wanted to ignore, or possibly better work with a part that doesn't have very good design intent. We worked with Modify Analytic when we wanted to take an existing radius or an existing angle and change it numerically. In this case, we're starting off with a 25 unit radius here in this lower left part, and we're changing it to a different value. This is going to allow us to change it starting with an existing value and changing it to a new value. Probably one of the most valuable things that I've found is definitely the pattern and symmetry recognition tool. For a moment, I'll start with symmetry. So the symmetry recognition is going to give us intelligence. This intelligence is going to allow us to make very complicated changes only one time. Any part related to that part that we just did in terms of symmetry will be updated automatically. Now, the same is true with pattern recognition. You'll note that earlier we changed that brake disc from 5 mounting holes to 6 mounting holes, simply by use of the pattern recognition tool to figure out what patterns were prevalent in the part that we had open. The remove tool was what we went over very early on. So very simple if we want to remove a hole. As we noticed earlier, in some cases it is a simple task to do in any parametric modeler. However, it's still going to be much faster, in our example about 10 times faster, with a flexible modeling tool such as Creo Parametric's flexible modeling. We can always remove holes, remove entire features, remove entire edges, simply by selecting and hitting remove. At this point, I'm going to hand it back off to Julian. Julian?
Thank you, Alberto. Again, thank you everyone once again. We're now going to open it up for some Q&A. Should you have any, we will stay on there for a few minutes and
So Alberto actually does have a couple questions that he's going to cover just now that we just got in.
Okay. The first question we received here happens to be the difference between move and offset. Now, that is a great question. So let me just kind of filter back up here to offset. Okay. So when we select a surface or a feature to move, move is going to allow us to move it about 3 axes and 3 planes. The example I'll use is those ramps that we talked about earlier. When I moved the ramp, I was able to move it in a specific direction, but I was able to also rotate it about that particular plane. That's why we're able to move it in 3 different directions. As for offset, offset will allow you to move something about a certain direction. If you select a radius, it will allow you to increase or decrease the radius. If you select a face, it will allow you to move it normal to that face. Okay. This example up here would have worked very well because we have selected the face and it would have only moved it normal to the face. However, I chose to use move simply because we do have the ability to use the move command about a specific edge or axis. The other question we had, just kind of reading this right now. Okay, so we primarily dealt with bosses. So it was boss or boss the secondary that I used. The question is cuts versus secondary and bosses versus bosses the secondary. What are the differences? Obviously, if we have a feature that is going to be a cut, it's basically going to select an inside boss, as it were. And the cut with secondary is going to select an inside cut with any type of related feature to that cut. Okay, I hope that makes sense. If there are any additional questions, I know that we did have that unit question that we answered earlier on. By all means, anything else, I would love to definitely try and cover everything. If you do forget something and you'd like to ask us later on, I will go ahead and show our contact information once again. You can always contact Julian or myself.
We do have a question coming in here. Give me just 1 second.
Okay, I see. The question is about the flexible modeling tab being missing after installing flexible modeling. During the installation process, there is actually an option to turn it on in Creo Parametric. So we can definitely take this offline and help you out. Just go ahead and shoot Julian an email or myself, and we'll definitely help you out. Yeah, so the question was basically flexible modeling was installed, but it is not showing up in the ribbon. There is a configuration to turn on for that.
All right, well, everyone, thank you. It doesn't seem as if there are any more questions.
So once again, we appreciate you taking the time out of your day to join us today for this demo. Thank you to Alberto for running us through the demo. Again, should any of you have any questions, please feel free to reach out to us. And just as a reminder, we do have a power hour this week. It is all around increasing engineering collaboration with Creo View and the different suite of solutions that entails. We all look for you to attend. That would be great. And again, that is all available on the NXREV.com website under training. So without further ado, thank you very much, everybody. Have a wonderful rest of your day and a great weekend. Bye-bye.